Question 22 has a square base pyramid. The slant height, so going up along here, is 20 centimeters and the base length is 16 centimeters. Now the first thing that they ask you to do is to find the perpendicular height of the pyramid to three significant figures. So what they're actually talking about is if you went from a point at the center of the base all the way straight up to the top, what that height is in there. So it's not actually on the face. So just to try and make it a little bit clearer, if we take a model of it here, we have our 1, 2, 3, 4-sided and square base. So it's not the perpendicular height, it's kind of confusing. It's not the perpendicular height of the face that they're interested in, but rather the perpendicular height in here where my pencil is resting. Okay, going from that point up to basically the tips. Now what happens is there's actually another triangle formed whose perpendicular height is the perpendicular height of the pyramid itself, because that triangle can be enclosed and the point is at the very top. So what we do is we take this internal triangle, okay, so it's an isosceles triangle with the base that goes along the diagonal of the square base, and what we do is we just cut it in half to form a right angle triangle. So if I pull that triangle out here on its own, okay, this here is going to be half the diagonal. Up here, that's our perpendicular height that we're looking for. And then over here is just our slant height. So the first thing I need to calculate is what half the diagonal is going to be. So we have a square base, side 16. We're looking for this here. So it's Pythagoras' theorem. So to get the diagonal squared is going to be 16 squared plus 16 squared. So our diagonal squared, 256 plus 256. So our diagonal is 16 root 2. Now I only need half of my diagonal, so I'm going to take that, 16 root 2, and divide it by 2, which is equal to 8 root 2, and this is our base. So for part 1 then, I have a triangle with a base of 8 root 2, slant height of 20, and the perpendicular height is what I'm trying to calculate because that corresponds to the perpendicular height of my pyramid. So 20 squared, 8 squared plus 8 root 2, all to be squared. Now I can't leave it in this form because it does ask me to give the answer to three significant figures, so I need it in its full form. So that's 16.4924225 is my height, and then to three significant figures, so 1, 2, 3, 9 is next, so I have to round it up. So h is approximately equal to 16.5 centimeters to 3 significant figures. So then part 2 of this question, they ask us to work out the surface area of our pyramid. So just to remind ourselves, our surface area of this pyramid will be 1, 2, 3, 4 triangles and 1 base. So for the surface area, or for the area of a triangle, I'm going to need the base, which I know, and I'm going to need the perpendicular height. Now I don't know this because this perpendicular height is not the same as the perpendicular height of the pyramid, which is what we just calculated. So I need to take this triangle and work out what that perpendicular height should be. So the information that I have regarding the face triangles is that their entire base is 16, their slant height is 20. So what I'm going to do is I'm going to create a right angle triangle, and I'm going to call this particular perpendicular height, I'm going to call that P. And I'm only going to be interested in half of it, so that's only going to be 8 centimeters. So 20 squared this time, 8 squared plus P squared. Equals P squared. Okay, so now I have to remind myself I have 4 triangle faces and 1 square base. So my triangle faces, they're going to be 4 times half the base. So this is the entire base of the face triangle, so that's 16, by the perpendicular height, which is my 18.33. And then here I have 16 times 16. So when I calculate that one, 4 times 0.5 times 16 times 18.33, I get 586.56. Okay, and 16 times 16 is my 256. Now, if I take more decimal places, which I have in my calculator for the 18.33 down here, I get more decimal places here. So just to show you, 569689. So when I add them together, I get 842.569. Sorry, 569689, which is then approximately equal to 842.57. So just be careful. I was trying to save space, but just be careful about rounding too soon. Hang on to all your decimal places for as long as possible and don't round to the last minute. That's the full surface area. So then the last little bit that we have to do, part 3. In part 3, we are told that a flat circular base circumscribes the base of the pyramid. So what that means is, if a circle is circumscribed on a polygon, it means the circle passes through all the vertices of the polygon that's given. Now obviously this is very difficult to draw, but you get the idea. Okay, so these points are all on the circle, okay, which looks really dodgy, but like I said, you get the idea. So what we're being asked to work out here is what's the radius of our circle. Well, instead of looking at it this way, let's have a look at this here. Okay, this diagonal line is equal to the diameter of the circle, because any line that goes from one point to another through the center is the diameter of the circle. So if I can calculate the diameter of, if I can calculate the diagonal line, I'll have the diameter of the circle. Then it's just a case of halving it to get the radius. So I know that internally I've got this little triangle that has now been created on my square base that measures 16 by 16. So if I want my diagonal here, so D for diagonal, or DIA, so we know what we're talking about, squared is equal to 16 squared plus 16 squared. So if this is looking a little bit familiar, it should do. I'm doing it out just for the sake of you seeing it, But if this does happen in an exam question, as you've seen before in tests, you're perfectly entitled to say, diagonal. You're perfectly entitled to say, you know, the answer is such and such as per calculation in the earlier part. That's perfectly fine. So the diagonal measurement is 16√2, which is also equal to the diameter of the circle. Therefore, we remind ourselves that the radius is equal to half the diameter. The radius is equal to a half times 16√2, or 16√2 divided by 2, whatever way you want to say it. So therefore the radius is 8√2, and this is in centimeters.